morning, Physics 30s. Today is Wednesday, February the 6th, 2019, and I am giving you this lesson because this is our fourth snow day in the second semester, and I'm providing this lesson to you so that you can do the lesson at home. I have Gmailed all of the workbook pages this morning to every student in our Physics 30 class, and you should be able to print the notes, and I will also Gmail the notes to you as well, so you have the teacher version. You should be able to print both the notes and the assignment, and please complete them for our next day with everybody here. When buses running will be Tuesday. Okay, so here we have momentum and impulse. Now, class, momentum and impulse is a concept. Momentum is a concept that you might have heard about prior to physics, right? But where have you heard the word momentum before? Where in everyday life have you heard the word momentum? Have you ever heard anybody talk about momentum, maybe in sports or in politics? Have you ever heard that before? Yeah? Liam, where have you, pardon me, student in the back, where have you heard that?
When you talk about a vehicle stopping, it has a lot of momentum, so you need more distance.
That's right, and you look at a vehicle, and when we look at momentum, I'll be presenting two new equations today. One of them is P is equal to mv, and P stands for momentum. It is a vector quantity because it has both magnitude and direction. And here, when we talk about how massive it is, right, one of the questions I have for you coming up is if we were to have two vehicles colliding, and you've maybe got a neon car versus a semi-truck, and they have a head-on collision, and they're both going at the same highway speed, which one is going to get more of the impact? What do you think?
The neon.
Just shout it out. What do you think?
Neon.
The neon. That's right. The one with the smaller mass is going to have more force applied to it, and it's again because the semi-truck has more momentum to apply to the other object. Good, good. Momentum, you might have also heard with the politician. The politician had lots of momentum in their speech. Right? They were giving a speech, and they had a lot of momentum. They had the crowd excited. They had everybody going. Also sports, right? You look at sports and maybe hockey, for example. One team may have a lot of momentum. They may be very, very difficult to stop. I know Dave, pardon me, students at the back. There are students in this classroom that may or may not play basketball, for example, and maybe a team that they're playing might have 20 points, or you have a 20-point lead, and you might be really tough to stop because you have a lot of momentum, really tough to stop. There we go. So we hear about the word momentum in many aspects of life. So here we can see momentum with the car. One of the students at the back had mentioned that. We also look at momentum with football and having a very large defensive player trying to stop the other player. Here are some questions I have for you to think about this morning. How does a karate expert chop through cement blocks with a bare hand? And I want you to think about, is it fast or is it slow? So go ahead and write down your response. We're doing some predicting this morning. Why does a fall on a high jump mat hurt less than on a cement floor? So think in terms of force, right? The amount of force that is being applied to your body. And the last one, go ahead and read on your own about the larger vehicles and what happens there. The other equation that I'm going to present this morning is called impulse. Now, impulse is a change in momentum. I'd like you to get out your formula sheets, please, everybody. We're doing the formula sheets out. We will see on our formula sheets that impulse can be equal to force times delta T or mass times delta V. And you will see it located right here on your formula sheet. Under momentum and energy. Here. With this here, if we get 3 of the 4 variables, you will use them all. You can use just what's on the right-hand side, or just what's on the left, and if you get 3 of the 4, you will use the entire equation. Now please write this on your formula sheet to the left. Write in delta P. I'll put an arrow over top. I'm going to just turn on my smart ink here. Also going to make this larger for us. You will never see on your formula sheet this symbol for impulse, but know that delta P is going to be, try one more time. So what I'll do then is I will just go over here. So please writing this off to the left of your equation. Now back to the lesson. If we look at the following here and we derive for force, we get the following. We're going to use this in answering these questions. How does a karate expert chop through the cement blocks? I have a cinder block at the back of the classroom, and if I wanted to chop through it with my bare hand, would I want to do it very, very quickly or very slowly? What do you think? Quickly. We would like to do it very quickly. And what happens here is that if we have a very short amount of time, we're going to increase the amount of force. Please write that down to the right of that.
Chopping a brick.
I have a little video clip to show you,
Normally,
just in case you've never seen
quite
this before.
interesting to watch. But let's see it again. Very slowly. At 4,000 frames per second, the hand of steel transforms into a wobbly mess. The 27 bones of the hand rattle around inside a clump of skin and fluid.
Keep in mind,
Shockwave
this is
can be
slow
seen
motion.
travelling through the
Sequels
arm's
is coming
fatty
up here right
tissue
away.
and across the surface of the brick in a cloud of dust. In real time, it takes a
Watch
tenth
how
of a
fast
second.
this is going.
A brick being karate chopped in two. One more, quick, but very slow.
For those of you at home, I will
Hello,
attach
I'm Gav.
the...
I'm Dan. Welcome to the
Pardon me.
Student Display
For
Show.
those of you at home,
Today we have the
if you
world's
really want to
fastest
see the
card
video
thrower.
again, we can
Oh,
play it
oh.
again,
He just disappeared.
or we can pause. We'll try that again. For those of you at home, I will attach the URL link for that video if you'd like to see it, as I have it just as a hyperlink in my presentation. Why does a fall on a high jump mat hurt less than on cement floor? What about force? How can we relate that back to force? Go ahead. Yes, force absorption. Now here, write this equation again. If you've ever missed the mat when you're high jumping in phys class, you know it hurts a lot. And you know here that if you do hit the mat, which is what you ideally want to do, you want to increase the time. And how would that affect the force? The force that you feel, would it increase or decrease? Good, and we know that because force and time, how are they related? Do you remember back to Physics 20? They are inversely related. Well done, good. And this is also how airbags work, that we want to, if you don't have an airbag and you hit the steering wheel, the force is being applied over a very short period of time. However, if you have an airbag, you're going to increase the amount of time which lessens the amount of force. Good. And the very last one, as mentioned before, that in the larger vehicles, you have fewer injuries. Again, that relates back to momentum, that you are going to apply more momentum to the smaller vehicle. Momentum is a product of mass and velocity. Now, please make sure on your notes, when I created these presentations, it would only allow me to do the following here, not to put in the arrows. So please make sure you put in your arrows above the P for momentum, as well as V for velocity, showing that they are vector quantities. The only acceptable units for this are going to be mass, must be in kilograms, velocity in meters per second. Let's have a look at the first equation. Now please note you must convert kilometers per hour to meters per second. You're going to write out what you know. And Ms. Skinner is actually Mrs. Schmidt, for those of you that met her just prior to Christmas. She's one of our social studies instructors. She taught here for many years. She's at home on maternity leave. And yes, I quite often like to give our teachers these cherry red Ferraris and Lamborghinis. We all like to dream. Make sure you convert kilometers per hour to meters per second. And there's your answer. Yes?
Do we have a simpler unit for kilogram meters per second?
No, we're going to find that the acceptable units here, good question. The acceptable units for momentum will be a kilogram meter per second. When we get to impulse, the two accepted units are going to be a Newton second or a kilogram meter per second. Now, the best answer for what you're going to see as far as the unit, if it asks for 1 unit for impulse, Newton second is going to be the best answer to choose. Okay? And the only reason being is because it cannot also be used for momentum. So that's the only